Hello, let us start questions on engine mechanics morning session. Actually, only one question has appeared from mechanics, and this question is based on friction and free body diagram. Let us look at the question. The question says a wedge M and block N are subjected to forces P and Q as shown in the figure. Let me show you the figure. There is a wedge M and there's a block N over here, and these are two forces. Okay, there are two supporting surfaces and one common surface between them, right? The question further says, if the force P is sufficiently large, the block N can be raised. So basically, if your P value is sufficiently large enough, you can lift this block N. That is the basic purpose of using wedges, is it not? Further, the weights of wedge and the block are negligible compared to the forces P and Q. What is this basic statement implying? This statement over here is implying, in your free body diagram, you are going to neglect the weight of the block and the weight of the wedge. Generally, the weight of the wedge is neglected as usual, but still block's weight also is negligible. Both of them are negligible over here. Further, he says the coefficient of friction along the inclined surface between the wedge and the block is 0.2. You can see over here, this surface alone is having coefficient of friction given as 0.2. All other surfaces are frictionless. So basically over here mu is equal to 0 and over here also mu is equal to 0. Only forces you are going to get over there are normal reaction forces, no friction whatsoever. Further, the wedge angle is 30 degrees as indicated in the diagram. The limiting force P in terms of Q required for impending motion of the block N to just move it in the upward direction is given by this relationship. P is equal to alpha Q. Okay, so that the block N is just about to get lifted up. Block N is just about to get lifted up. The value of coefficient alpha is equal to how much? Rounded off to 2 decimal places. Okay. Now we are going to start with the free body diagram, but before doing that, let us first of all think about the friction, because friction will be critical over here. Okay. To understand the friction, I always tell you that whenever you are having these mating bodies, these kind of bodies are called as mating bodies. Whenever you have these mating bodies, always try to look at the relative motion of mating particles. Let us say I have a particular particle over here, which is in block N, and I have another particle over here, which is in wedge M. Let us say these two particles are mating particles. Should the block N be lifting upward, what is happening? This particle which is in N is trying to move in this particular direction. Just imagine, I am pushing the wedge. If I push the wedge, the block relatively is moving in the backward direction. If the block moves in the backward direction, for the block, the friction is supposed to come in this direction. Please understand, friction does not oppose motion, friction opposes relative motion. That is why I am concentrating on relative motion over here. So the friction on the block is supposed to come in this direction, and the friction on the wedge, since this is action-reaction pair, you are supposed to get the friction on the wedge in this direction. If you have understood this, rest of the free body diagram is a cakewalk. It is going to be extremely easy for you, right? Let us see. Let us draw the free body diagram now. Let us say I have the block over here, and I have a habit of drawing the mating bodies together so that you can understand the free body diagram better, right? So I have the block, let us say block, and this over here is the wedge. Angle is 30 degrees. Please do not scale my diagrams, right? The forces which are applied forces are P and Q. So let me mention over here. 1 second. Yeah, I'm having a P over here. I'm having a Q over here. I'm having a Q. A statement has indicated that we are not going to consider the weights of both these things in the free body diagram. That is fine. Moving further, I'm having two surfaces, surface 1 and surface 3. I would keep in mind their names or numbers and use the same numbers for normal reactions. Let us say this is normal 1 I'm having, and this over here is normal 3 I'm having. Then there is an action reaction pair between these two, that is normal 2, let us say. I have over here normal 2, and an action reaction pair implies I should have over here a normal 2. Furthermore, I'm supposed to have friction. Now I have already indicated for the block the friction is down the incline, for the width the friction is up the incline. So let us say I have a friction over here. This value of friction is supposed to be equal to mu times n, that is 0.2 n2, and the value of friction over here, okay, is supposed to be equal to same thing, that is again this is an action reaction pair times n2. One more thing, for the sake of easiness, let me do one more thing over here, and that is, if I take a reference, if I take a vertical reference, this angle and this angle, both of them are equal to how much? 30 degrees. These angles are equal to 30 degrees. Now let us start. I'm starting with the block B first of all. I'll start with the block B. So for block B, if I draw my free body, I have my free body diagram already. Let us straight away start with summation of F in vertical direction is equal to 0. See, it is a case of impending motion. Impending motion means the motion is just about to take place. So still you are within the static limits. Therefore, I'm having sigma Fy is equal to 0. If sigma Fy, equilibrium is still valid, right? Sigma Fy is equal to 0. Then what do I have over here? Vertically upward direction, I'm having a force N2, and there's going to be a cos component contributing towards that. So let us say I have over here N2 cos 30, N2 cos 30 degrees. Downward direction I'm having Q, so minus Q, minus. Now you see F is also going to have a component in the downward direction, is it not? Now that component is going to be F sine 30. So therefore I'm having 0.2 into N2 into sine 30. This is supposed to be equal to 0. Now what have I got from here? I have got an equation in terms of N2 and Q alone. So what I'll do is I will obtain the value of N2 in terms of Q. So I see the value of N2 common to cos 30 minus sine 30 is equal to Q, which implies N2 is equal to Q upon cos 30 minus sine 30, the value of which comes out to be equal to 1.3054 times Q. Let me save this as some equation number 1. Now what I'm going to do is I'm going to extend this value of N2 for the next wedge. So I'll say for wedge W. Now what have I got over here? In this case, when I talk about the wedge, let me over here talk about sigma Fx is equal to 0, right? Sigma Fx is equal to 0 would imply what? Let me write. Sigma Fx is equal to 0. Again, you are within the equilibrium limits because impending motion is mentioned, right? So what have I got? If I take right hand side direction as positive, I'm going to have now N2 is having a component towards the right hand side, and that component is N2 sine 30. And F is also having a component towards the right hand side, and that component is F cos 30. So therefore I have plus 0.2 N2 cos 30, cos 30, cos 30. And I have P, which alone is in the left hand side. So minus P is supposed to be equal to 0. Minus P is supposed to be equal to 0. Now, I have over here, one moment please. I have made a small printing mistake over here. This is supposed to be 0.2 times sine 30. Please be careful regarding that. So I have over here N2 times sine 30 plus 0.2 cos 30 is equal to P. Now if I put the value of N2 as 1.3054 Q, I'll go to the next slide. Okay, I have N2 as 1.3054 Q is equal to P divided by sine 30 plus 0.2 cos 30 plus cos 30. So he has asked me the question regarding P in terms of Q. So I can say P is basically going to be equal to, if you calculate this entire thing, P would come out to be equal to 0.8788 times Q. This is a value of P. Let us look at the options, what he has given. He has given me the options as 2, 0.5, 0.6 and 0.9. I see my answer is very close to 0.9. Therefore, I'll say this is approximately going to be equal to 0.9 times Q. P is approximately equal to 0.9 Q. So the answer for this question is option D. Now, what is the critical point? After having completed this question, let us look at where you could commit mistake and which point is going to be very critical over here. The most critical point is already mentioned over here. It is deciding the direction of friction. People are not worried regarding the normal directions, they get it very easily. It is only with friction they get trouble whenever you're having wedge problems. Okay, whenever these kind of problems come in, always think of mating particles, and when the motion is impending, try to visualize that motion impending and decide what is the relative motion of mating particles with respect to each other. Once you decide that, friction is just going to oppose that particular motion, right? So the answer for this question is 0.9. This was the only question that appeared from mechanics in civil paper. Thank you.